Good morning, friends. Already we discussed in this chapter the reflection by the surface, plane surface separating the two medium, and also the reflection by a spherical surface, and also reflection by a thin lens. Okay. Now, today we are going to discuss about the reflection through a prism. Reflection through a prism, and we have to obtain the equation I plus E is equal to A plus delta. I is the angle of incidence, E is angle of emergence, A prism angle, and delta is angle of deviation. Now, before starting our discussion, this question is asked for this year in board exam for 2 marks. Actually, the answer is quite lengthy, but there is asked for 2 marks. Okay. Now, before starting the answer of this question, here in this chapter, ray optics, here we are using the light. Light are two types. One is the chromatic and second is the monochromatic. Chromatic and monochromatic. What is the chromatic light? Chromatic light is made up of the 7 colors, that means the 7 wavelength. From red to violet, actually this chromatic light is a white light. That is the white light. That is the combination of the 7 colors. The sunlight is also a chromatic light. What are the light coming from the white bulb? That is the chromatic light, or the white light. That is the combination of the 7 colors. Now the monochromatic light, the light having the single wavelength, light with single wavelength, that is known as monochromatic light. Single wavelength. Like as the light coming from the sodium lamp, yellow light, or the orange light, that is the monochromatic light. Here we are using the monochromatic light. What's happened if we are using the white light? If the white light passing through the prism, so emergent ray is not a single ray, that is divided into the 7 color bands. That means the dispersion of light take place as we are using the chromatic light or the white light incident on a prism. And due to that reason, in this here we are using the monochromatic light. Monochromatic light is the light with the single wavelength. Okay. Now, first we give the diagram what's happened as the monochromatic light is incident on a prism. Here, there is the ABC is the prism. Now, there is the perpendicular diagonal at point Q on surface AB. There is the Q point. A of monochromatic light, there is the PQ, incident at point Q. So, according to the Snell's law, there is the reflected as QR. Reflected as QR. That point is R. Here, there is the air medium, having the reflect index in 1 is equal to 1. Now, there is the glass medium. Prism is made from the glass medium. Here the reflective index in 2 is equal to 10. Now this reflected AQR incident at point R on SC surface, and due to that reason we give the normal at point R. This incident AQR, according to the Snell's law, there is reflected as RS and emerges out from the prism. And emerges out from the prism. Here, angle of incidence is I, here the angle of reflection is I1. This QR ray incident at point R on S surface at angle of incidence R2. Here, the angle of emergence is E. Angle of emergence is E. Now, as we extend the incident ray PQ to PQE. That is the ray PQE. That is the direction of incident ray PQ. And as we extend the immersion ray in that direction, so both rays meet at point M. Therefore, the angle between incident ray and immersion ray, that is the angle of deviation delta. Angle of deviation delta. Okay. Now, at point Q on the surface AB, when the monochromatic light ray is reflected, so its path is deviated by angle delta. Delta. Similarly, when the QR ray is incident at point R on AC surface and reflected, therefore its path is deviated by angle delta 2. And this point is our end point. Now we have to discuss this figure. So first we have to enter the description of this figure. As shown in figure, again the ray PQ of monochromatic light is incident on surface AB at point Q, and according to the Snell's law, it is reflected as QR. This ray QR incident at point R on AC surface and emerges out as RS ray. Okay. The PQs are deviated at angle delta 1 and QR rays is deviated at angle delta 2. Now, the incident ray extending to PQE and immersion ray RS is extended in that direction. Both rays meet at point M. Therefore, the angle between the incident ray and immersion ray, that is known as the angle of deviation. We have to write out here, that is necessary for the description of figure, and due to that reason, X shown in figure. A ray PQ of monochromatic light. Monochromatic light is incident at point Q of surface area. According to Snell's law, it reflected as QR. Reflected as QR. This deviation, the inner deviation, the deviation of QR from direction of incidence is delta 1. Now, ray QR incident on surface AC at point R and emerges out as RS ray. The deviation of QR ray is delta After that third. Now extending the PQ ray to PQE. A PQA extending to PQE and immersion ray as extended in back direction. Both meet at point A. The angle between incident ray and immersion ray is known as angle of deviation. Known as angle of deviation. Okay, how we derive this relation I plus E is equal to A plus delta? For that purpose, from figure, quadrilateral AQ in R. AQ in R. Angle AQN. This angle AQN and ARN, this angle is equal to angle ARN is equal to 90 are right angle. Therefore, the addition of angle A and Q in R is equal to 180. Therefore, angle A plus angle Q in R is equal to 180 degree. That is the equation. Now, for triangle, here we consider this triangle Q in R, this triangle. The addition of its triangle R1 plus R2 plus angle Q in R is also 180. For triangle Q in R, Q and R, R1 plus R2 plus angle Q in R is equal to 180 degree. There is your equation number 2. Again, here we consider first the parallelogram AQ in R or the quadrilateral AQ in R. Here the AQN and ARN are 90 degree because this is the normal at point Q on AB surface and also there is the normal on AC surface at point R. Therefore, this angle is of 90. 90 plus 90, 180 plus A plus this angle Q and R is equal to 360 for quadrilateral. And due to that reason, A plus this angle Q and R is equal to 180. That is our first equation. After that, we consider this triangle Q and R. The addition of I1 plus I2 plus Q in R is also 180. Now, comparing equation 1 and 2, because the right hand side are same. Right hand side are same. Therefore, comparing equation 1 and 2. So what's happened? Right hand side are same. Therefore, angle A plus angle Q in R is equal to R1 plus R2 plus angle Q in R. That is cancelled. Therefore, A is equal to R1 plus R2. There is a third equation, and that is the important equation frequently we are using. So that is known as the PRISM angle A is the addition of I1 and I2. Now, for triangle MQR, delta is an exterior angle. Now, for triangle MQR, delta is an exterior angle. Therefore, delta is equal to addition of MQR plus MI2, angle MQR plus angle MIQ. That means the delta is equal to delta 1 plus delta 2, equation 4. Delta is equal to delta 1 plus delta 2. And also from figure. Now listen. This angle of incidence is same as this angle. I is equal to delta 1 plus I1. From figure, I1 is equal, I is equal to angle of incidence is equal to I1 plus delta 1. Therefore, delta 1 is equal to I minus I1. I minus I1. Similarly, on this side, the angle of emergence E is same as the I1, I2 plus delta 2. And E is equal to I2 plus delta 2. Therefore, delta 2 is equal to E minus I2. Substitute in equation 4. Substitute in equation 4. Therefore, our equation delta becomes, instead of the delta 1, this value, I minus I1 plus delta 2, E minus I1. We add this equation in that form, I plus E minus sign common, I1 plus I2, that is the delta. Now, from equation 3, I1 plus I2 is equal to A. From equation 3, I1 plus I2 is equal to E. Therefore, delta is equal to I plus E minus E. Take the A on LHS, therefore F plus delta is equal to I plus E. So, this shows the relation between PRISM angle, angle of deviation, angle of incidence, and angle of emergence for a prism. Very easy, quite lengthy answer, but very easy. Again, how we obtain this answer? For that purpose, we consider the prism. APQ incident at point Q on any surface. According to the Snell's law, there is a reflected as QR. This reflected ray incident on surface SC at point R and emerges out as RS. Delta 1, delta 2 are the angle of deviation. Okay. As we extend the incident ray in forward direction and emergent in back direction, both meet at point M. Therefore, this angle between the angle of incident ray and emergent ray is delta. Okay. Now, how we deal in form of the equation? For that purpose, first we consider the quadrilateral PQ and R. And we obtain the equation A plus Q and R is equal to 180. After that, we are using this triangle Q and R. So here Q and R plus R1 plus R2 is equal to 180. And then we compare these two equations. We obtain the A is equal to R1 plus R2. After that, considering this triangle MQR, delta is an exterior angle. Therefore, delta is equal to delta 1 plus delta 2. After obtaining this equation, delta is equal to delta 1 plus delta 2. In this equation, we have substituted the value of delta 1 and delta 2. How we obtain the delta 1 and delta 2? So, from the geometry of figure, so this angle I is equal to R1 plus delta. Therefore, delta 1 is equal to I minus R1. Similarly, angle of imbalance E is equal to R2 plus delta 2. Therefore, delta 2 is this. After substituting these two value in equation 4, we obtain the A plus delta is equal to I plus E. That is the important relation for equation. Clear this? Okay, after we obtain the equation I plus E is equal to A plus delta. Now we are going to do the graph of angle of incidence to the angle of deviation. Because the angle of deviation depends on the angle of incidence. Yes, the different angle of incidence we obtain, we keep. So angle of deviation is also seen. Also, we perform this experiment in practical. We have to do the graph of the I plus I versus delta. From this graph, we find out that the value of the delta is minimum for a particular value of angle of incidence, for which the angle of incidence is equal to angle of emergence. Again, yes, we do the graph for I versus delta. So graph is this way. There is the angle of incidence. There is the I, and there is the angle of deviation. That is delta. So we obtain the graph is like this way. For this particular value of angle of incidence, we obtain the delta is the unique value, and that is known as the delta minimum, that is the DL. Yeah, for this value of I, the angle of incidence and angle of emergence both becomes the same, and then the delta becomes the minimum. While for the other value of angle of incidence, two different value of angle of incidence, we obtain the same value of delta. Same value of delta. So from the graph, the angle of deviation delta becomes minimum for particular angle of incidence I, for which I is equal to the angle of incidence for which the I becomes I is equal to E. For only for this angle of incidence, the delta becomes the minimum, and it is known as the minimum angle of deviation. Minimum angle of deviation. While for other two value of I, delta remains same. Now, for I is equal to E, the angle of deviation is minimum is called minimum deviation angle. Therefore, for I is equal to E, delta is equal to D. Delta is equal to dm. That is the minimum deviation. Minimum deviation. Whereas, so that is the description of a graph of delta versus R. Only we have to describe that, and also we perform this in experiment. Now after that, for PRISM, question is that using equation I plus E is equal to A plus delta E for PRISM, and obtain equation of refractive index of a prism. Or in other words, obtain n is equal to sine A plus dm by 2 upon sine A by 2. Sine A by 2. So, that is for the prism. Therefore, we need to accept this equation I plus C is equal to A plus delta. Therefore, for a prism, I plus E is equal to A plus delta equation 1. Now, for I is equal to I, delta is equal to dm. That means the minimum deviation. Minimum deviation. Then substitute in 1. In equation 1. Therefore, we obtain I plus E is equal to I plus E, that means the I plus I is equal to A plus delta M. Therefore, 2I is equal to A plus dm. Therefore, I is equal to A plus dm by 2. There is a second equation. So, this way we obtain the value of angle of incidence. Now, remember our figure, we are applying the Snell's law at point Q on surface area. Now, applying Snell's law on surface area. There is N1 sine I is equal to N2 sine R2. N2 sine R2. There is a equation number 3, and for surface AC, here N1 sine E is equal to N2 sine R2. Equation number 4. So, for these two surfaces, already we have the information about the figure. This figure, here the prism, there is the ABC surface. Here the endpoint Q, that is beyond the normal, and also at point R, there is also the normal. There is the PQA, and there is the QR, and there is the inversion ray RS. So there is the angle of incidence I, there is the R1, there is R2, there is the E. Now listen, here the medium is A medium, N1 is equal to 1 for A medium. This side is also A medium, N1 is equal to 1. Now here, this point is our A. There is a glass medium. Prism is made from the glass. the factor index is N2 is equal to N. There is the denser medium. Ray of light traveling from there to the denser, and here denser to the there. Okay. Therefore, applying the Snell's law, here N1 sin I is equal to N2 sin I1. N2 sin I1. And for surface AC, this surface AC, here N2 sin I2 is equal to N1 sin E. N1 sin E. Here is okay. Now, for minimum deviation, the condition is that I is equal to E. Therefore, equation 3 and 4, I and E are same. Therefore, the left hand side of equation 3 and 4 are same. For minimum deviation, I is equal to E. Therefore, compare equation 3 and 4. 3 and these two equations I compare. Why? Because for minimum deviation the condition is I is equal to E. Therefore N1 sin I. While in equation 4 left hand side is N1 sin E. Instead of the E we substitute the I. Therefore N1 sin I, N1 sin I. Left hand side of these two equations are same. Therefore right hand side must be same. Therefore N2 sin I1 is equal to N2 sin I2. Therefore N1 sin I1 into sin I1 is equal to N2 sin I2. Into cancel. Therefore sin I1 is equal to sin I2. Therefore I1 is equal to I2 is equal to R. We say that there is the R. That is our equation number 5. But we already know that A is equal to I1 plus I2. A is equal to I1 plus I2. But here I1 is equal to I2. Therefore, A is equal to 2R. Therefore, R is equal to A by 2. That is equation number 6. So thus we obtain the value of I1 or the I2 or R is A by 2 and also I plus delta M by 2. Now substitute this value of I and R in equation 3. Substitute equation 2 and 6 in 3. In equation 3. Equation 3 is N1 sin I. Therefore, N1 sin I is equal to what? A plus dm by 2. A plus dm by 2 is equal to N2 sin I1. N2 sin I1 is equal to I2 is equal to R, but I is equal to A by 2, therefore A by 2. But we know that N1 for A medium 1 and N2 is equal to N for prism of the glass. Therefore, N is equal to this side A by 2, this side. Therefore, sin A plus dm by 2 upon sin A by 2. So, this is a required equation that represents the effective index of material of a prism. This is the equation of the effective index of a prism. So, there is also important question to obtain the equation of the effective index of the prism by using this equation I plus A is equal to A plus B. So that is also important, maybe asked for 2 marks question only the mathematical terms. Here we accept I plus A is equal to A plus delta, and this condition for the minimum deviation I plus A is equal to delta. When the I is equal to E, then the delta is equal to delta M, and also we accept this A is equal to R1 plus R2. Here is very easy, but we have to write down the 1 or 2 times in notebook. So So we can clear about this. And here the figure is not important, but when we are applying the Snell's law, at the time we know that what is the R1, what is the I, what is the E, what is the R2. For that purpose I do this diagram, but in the answer of this question figure is not required. But if you do, so that is well and good.